All right. Algebra 1B on Wednesdays, we wear pink. Okay?
Yeah.
September 9th, 9-9. Next VBA, students will be able to solve equations for a specific variable, 0.9. What else does it say?
Test next Wednesday.
Heads up, next Wednesday we'll be testing a week from today, okay? We'll be reviewing on Monday, testing on Wednesday.
How many questions are on the test?
5,000.
Okay, good. 5,000. Good. I was hoping you'd say that.
You're welcome. Okay. So, this time we're going to solve for a specific variable. So in this case, we look at number 1. 15 equals 2n plus 6p. How many different types of variables do you have? 2. So before, on the homework we just turned in today, okay, but that we're not doing right now, okay, we had the same variable multiple times. This time, we have multiple variables. In this case, we don't know what variable to solve for unless it tells us. So number 1, what variable does it tell us to solve for? N. So we want to get n by itself. So when we have 15 is equal to 2n plus 6p, we want to treat this n like we would have treated any of our variables before.
Why does it feel like my time?
I don't know.
As if you're on the outside.
So what's happening with our variable n? We multiply by 2 and added by 6p. Now before, if this was just 6 instead of 6p, if I just cover that p up for a moment and I just say that's 6, what would I want to do with this equation first? Subtract 6, right? I do the nice sad method. So I'm going to do the same principle here, but instead of subtracting 6, I'm going to subtract 6p. Because what is 6p minus itself? 0. Anything minus itself is 0. I'm going to subtract 6p over here. Now here's the thing. I could do 15 minus 6. Can I do 15 minus 6p? No, but I can write it.
Oh, this is the worst one.
So do you guys remember? You guys remember how when we couldn't do our fractions yet, we couldn't because we needed to call them denominators, we still just kind of wrote it out? Aiden. Focus up. Follow up. Okay. Go right up. So we couldn't when we couldn't add and subtract fractions yet because we had to get common denominators, we still just wrote it out. Same idea here. We're gonna write it out even though those are not like terms. 15 and 6p. Can't combine them. But we can write it out and we're going to leave it like that. So now, is n by itself yet? No, what do we have to do? Divide by 2. So we're going to do that. But now we divide the entire side by 2. Okay? That's the spirit. Alright. Can we just straight up divide 15 minus 6p by 2? No, but we can write that. 15 minus 6p divided by 2 equals, what's 2n divided by 2? Just n, because the 2's, the 2's do what? They reduce.
Cancel.
No. And this is our answer. Because n is by itself.
Or remember these.
Does that look like it should be an answer to us?
No.
No. So it looks weird to us. But we have to say at the end of the day, we wanted n by itself. Is n by itself?
Yeah.
Yep. Can I really do any more math with my math here? No, I can't. And we're going to have to just be okay with that. Okay, questions on that? So that's the answer. Okay? So if you're struggling sometimes with what do we do first, a good hint, a good helpful thing is like do what I do. Cover up your other variables that you don't need. And say, okay, well, if I was just adding 6, what would I do? Oh, I subtract it. So in this case, if I'm adding 6p, I'm going to subtract 6p. Or in your backpack. Thank you. Number 2, I said letter 2. Number 2, k minus 2 equals 5, or k minus 2 over 5 equals 11j. So you have two different variables, k and j. Which one is it asking us to solve for? K. So what's happening with k? We are doing what and what? Subtracting by 2 and dividing by 5. Now what would we have to do first here?
Add 2.
We would like to, but can we add 2 right now?
No.
3. No, we have to multiply by 5 first.
Oh.
Because 2 is part of the fraction. Remember, that's one of our tricky ones. We have to multiply by 5 or 5 over 1 on both sides. What happens with this 5 and this 5? They reduce to 1. So we have k minus 2 equals 11j times 5. 55j. What's up, Mason? Okay. You don't want to say it? What is that?
It's like K, it's like R.
Everyone says, I get this every single class. And my K's look like R's. I've been writing my K's like that since I was in elementary school. So what my teacher told me to do, okay? If you want to have beef, you can take it up with Mrs. Hagemeyer in first grade, okay?
How do you know your first grade teacher's name?
Oh,
I
there we
forgot.
go. I had Mrs. Cards in kindergarten.
I had Miss Ray.
I miss Morrison in
Oh.
kindergarten.
I had Miss Ray.
Yeah. Oh, yeah.
I had Miss Ray. I missed my first grade.
All right. So now, is my K by itself yet?
Your R.
No.
Fine, it's fine. R by itself yet. So, what's happening with it?
It's
So times by 2, okay? I'm going to add 2. What's negative 2 plus 2? 0. Those cancel out. K equals, do I know 55j plus 2, can I combine them? No, they're not like terms, but can I write 55j
Yeah.
plus 2?
Yeah.
Yeah, it's k by itself.
Yes, sir.
We're done.
Is your R by itself?
Alright.
I'm trying.
He's about to give you an F minus.
Didn't you just have to do that?
You just gotta
You
write
never
them
had
right
those
again.
teachers who know
Just
why,
put
but they can give you an
like
F minus.
Okay, you ready?
Yeah.
Yeah.
They're the ones who
Go down.
grades.
Okay.
Back up. Curve.
That's an R.
That is an R with a bigger line on the top.
That's such an R.
That's a K.
It looks like a person.
It does. It does. If you just add two little legs, it looks like a person reaching up into the sky
Damn, dog.
or hanging off a
Are
cliff.
You should dock her grade to an F minus.
Oh, I can't do it. Alright, I'm gonna try doing
It literally looks like a person.
It does actually.
Make a little face and all the smile like this and be like, it's a person.
Like a juice, make a cliff.
oh, I don't have my thing where I can do the. Oh, there it is. Hey, look, it knows it's a K.
No.
No, it's
It
not.
knows
It's
a
an
K.
R.
Did it show up as an R?
I couldn't
Probably
say.
just say no. Right
What did it
here,
show up
R.
as? What did it show up as?
That's not right.
Right here, R. No, yeah, let me see your R.
The program tells me that's an R.
No,
Oh,
your capital
my
R.
capital?
Okay, now do your capital K. Oh my god, no. Like your K. Your lowercase
Oh.
K. They look the same.
What?
They look the same. Do they not? Do they not?
It just has a bigger line on the top.
Hey, this computer knows it's a K.
Why were you talking?
I think your computer's
It's like,
wrong.
wait, it's like the K, the line that goes like that is like curved.
But that doesn't make
They
sense
look the
because
same.
it literally looks like an R.
It does, but it's
Alright, continuing on.
because I've seen it.
2w minus y equals 7w minus 2. 2w minus y equals 7w minus 2. 4w. But it's always for w. Well, here, how many w's do we have?
2.
So what's going to be our first step, maybe?
Combine them.
Get them together. So would you rather move our 2w or our 7w? 2w, because then we're going to subtract it. We're going to end up with a positive number. So let's do that. So don't forget, this is a negative y. Don't just put y. This is a negative y. Equals, what's 7w minus 2w?
5W.
5w minus 2. Now what?
I don't really know.
Reagan's on a roll over there.
Do we add 2 to W?
We'll add 2 to both sides. Because we want to get w by itself. Do we know what negative y plus 2 is?
No.
No, we can write it. Equals 5w, and negative 2 plus 2 is 0. So now what would you do?
Divide by both sides.
Divide by 5 on both sides, because that's what's with the w.
Where does the 5 go?
Okay?
Oh, I
Do we we know what negative y plus 2 divided by 5 is? No, we can write it. And what's 5w divided by 5?
W.
W. Negative y plus 2 over 5 equals w. Woo-hoo!
We did it.
You did it.
Finally.
Hey. Hey, how about you write on your paper instead of writing on your cell phone? Is that fair? Cool. Alright, question on number 3.
You have the adults that aren't kids right now, so.
Well, no, I just wanted to actually do the
Well, no, I
stuff,
mean,
just
like,
practice themselves.
Yeah, they're just really.
No, like when I need somebody to remember, I'll write it on my hand.
Why
So
can't
now
I
you're
read
back
that?
from that.
On my head,
Yeah.
and I won't be able to see it.
No, it's only if you get it in your bloodstream.
True.
Or
But
if you eat it.
Okay.
I mean.
Alright. Hey Mason, why don't you pick a color?
Yeah.
You just had an L and you get
No,
no.
in order for that to happen, we had to like swim in the
Right.
pool.
Thank you.
Yes.
Good job.
Okay, number 4. 3/4 A, 3/4 times A minus X equals K. And solve for A.
That doesn't
R.
matter.
So,
Yeah.
what would we do first here?
Amazing.
What's happening with our A? That's our question. What's happening with this variable? Is there solve-
It needs to be by itself.
It's
It needs to be by itself. It's being multiplied by its fraction. And what else?
subtract.
Subtract. What do we take care of first?
3/4 A minus X equals 3 add M equals R.
We add what?
X to the
Add X to both sides. Very good, Tucker. We'll do SADMAP. We'll add X to both sides. Negative X plus X is 0.
Whoops.
3/4 A equals, do we know what K plus X is? No, but we can write it.
Ooh.
Alrighty. So 3/4 A is equal to K, yes, that is a K, plus X. Now what do I have to do to get my A by itself? Aiden, what would I do to get my A by itself?
Hang on.
Yep. Hang
No,
on.
you would divide 3 over 4.
Okay, close.
Like
So you're, I see you're doing division to try and get rid of 3/4. We have to multiply by B.
Oh, numeral. Or no, reciprocal.
So what's the reciprocal of 3/4?
You do 4/3.
On both sides. What's going to happen with this 4 and this 4?
Okay,
No.
no, reduce.
There you go. What's going to happen with this 3 and this 3?
Reduce.
Yep, so we're up to A. Now here's the thing. I can distribute in my 4/3, but that's not really going to get me anywhere. I'm cool with leaving it like this.
Yo.
Oh, I didn't
Right?
know that.
I think so.
Sweet.
I think it's single ability.
Joe and Lady.
Any questions on that one?
Yeah.
Now, there's a reason we're doing this. Okay, so there's a reason we're doing this. Sometimes, especially in science, and you might have encountered this in science even last year and this year. Okay, it's helpful to solve for a variable first when you have it like this, because then we'll start plugging things in. And if you plug the same thing in over and over and over again, like you're trying different values for the same variable. Like maybe in science you're trying to figure out different distances, like what it might be if the distance is this, or the distance is this, or the distance is this, or maybe if the time is different each time. Instead of plugging in the same variable and then solving each time, it can be easier to solve once and then just plug in the variable. I'll show you what I mean right below this. What's up, my dude?
Saving your tape, that's history.
You're what? You're
What
saving
is
my tape.
Hey,
I'm kidding.
mask.
Yes, okay. So find the value of y given different x values. So here we have the equation 6x minus 2y equals 4. 6x minus 2y equals 4. We're supposed to find the value of y given the different values of x. So there's two ways we can go about this. We can plug in x equals -1 and then solve for y. Then we can plug in 0 for x and then solve for y. And plug in 2 for x and solve for y and get 3 different answers that way. Now it's going to take a little bit longer than if we solve for y once and then plug them in. If we solve for y once and then plug them in. It's going to actually be faster here. So let's solve this equation for y. So we ask ourselves our big picture question. What's our big picture question each time with these? What is happening? What's happening with our variable? What's our variable we're trying to solve for?
Well,
Y. What's happening with our variable y?
Multiply by -2.
Multiply by -2 and
Subtracted by 6x.
it's subtracting from 6x. So what are we going to get rid of first?
6x
The 6x. How do we get rid of a positive 6x?
minus 6x.
Subtract 6x. Did everyone track with me why we did that? Be honest.
Sure.
Okay, that's not I feel like you're not doing it.
Sure.
My
Okay,
head's like going like.
okay, let's try this again. So, Laney, if this was 6 minus 2y, that x wasn't there, equals 4, would you want to get rid of the 6 or the -2 first? Okay, so when it becomes 6x, we don't change anything. Instead of subtracting by 6, we subtract by 6x. But what we would still do first stays the same. So if you're struggling on what to do first, cover up the other variables for a second and then go from there. Mason,
is that a comma?
it's a semicolon.
That's what I mean.
Yeah.
Why is that just
Because there's, we're solving for this, and then we're finding the value of y, what y equals, given different values of x. So here's our equation, but we're given these 3 different values of x to plug in. So it's just saying, hey, here's your equation, semicolon, here's more information.
Oh.
But it's not part of the equation, so we put a semicolon there to know it's not part of the equation.
Oh.
Yeah. What is 6x minus 6x?
0.
0. Negative 2, I don't forget it's negative, is equal to negative 6x plus 4. We like putting our x's first, so but it's negative 6x plus 4. Because the negative travels with that 6x. Go and write that down if you haven't already. Go and write that down if you haven't already. Okay? Is y by itself yet? No, what's still happening with it?
-2.
We multiply by -2. How do we get rid of this multiplication?
I had to
Divide. Times that by -2. -2 divided by -2 is just 1, so we have y. Now wait a second. When we divide by -2 here, does -2 go into both -6 and 4?
Yeah.
Yeah, so we can actually simplify that out. Before, if we look up at number 1, did 2 go into both 15 and -6? No, so we wanted to stop there. But here, -2 goes into both of these, so we can divide both of them. So what's -6 divided by -2? Yep, 3x. And what's positive 4 divided by -2? -2. So we end up with y equals 3x minus 2. See that there? So the only reason I did it here, but I didn't do it on number 1, why we did it here, but we didn't do it on number 1, is because here, 2 goes into both 6 and 4. Before, 2 didn't go into both 15 and 6. Might be a good idea, buddy. Yeah, it's a nice idea, thank you. So now we have y by itself. So we're primed and ready to plug in these different x values. Because we already have it set up to solve for y. So what we're going to do now is we're going to try this equation when x equals -1. Because we're asked to figure out the value of y given each of these x values. So we're going to figure out the value of y if x is -1. So we're going to try when x is -1. Y is equal to 3 times -1 minus 2. We're going to try it when x is -1. We're going to figure out what y is when x is -1. Go and write this down. And we're going to do 3 different ones of these because we're going to do it when x is -1, when x is 0, and when x is 2. So we're trying to figure out our big problem is trying to find the value of y in 3 different instances. Trying to figure out when x is -1, when x is 0, and when x is 2. So right now we're trying to figure out what is y when x is -1. So we plug in -1 for x. Now, 3 times negative 1 is what?
-3.
Negative 3 minus 2. What is negative 3 minus 2? Negative 5. So when x is negative 1, y is negative 5. Now, is it faster to plug in negative 1 into this equation in blue, or into our original equation in the black? The equation in the blue. That's why we did this. It's because it's faster to plug it into this equation in the blue. Why is this one faster?
Because
It's less
it's shorter.
steps.
Because it's what? Less steps? Then what do you say, Mason?
Shorter.
It's shorter because y is already by itself. Okay? Let's try it plugging in when x is 0. So y equals 3x minus 2. Y equals 3 times 0 minus 2. What is 3 times 0? 0. We have to put 0 minus 2. What is 0 minus 2? Negative 2. So y is negative 2. What one was faster, plugging it into this red equation, or if we plugged it into the black equation? The red equation. Once again, that's why we did it, because we're plugging in 3 different things here. So we solve for y 1 time, and it makes our other 3 steps way easier. Then if we plug each of these into this original equation, okay? So we solve for y once, rather than 3 times. Does that make sense? So sometimes this is actually easier for us. Now we're going to try x equals 2. We're going to plug in our last one when x is 2. Because we're asked to find y for each of these. So instead of y equals 3x minus 2, it's y equals 3 times 2 minus 2. And we're asked to find y for each of these x values. For different values of x. So we did x equals negative 1 in the dark blue, x equals 0 in the red, and now we're doing x equals 2 in the light blue. Can you open the map for nobody? Can you open the map for nobody? Okay. Alright, what is it, yeah, Maddie? Oh, nice. What's 3 times 2? 6. Looks like you didn't even miss it. What is 6 minus 2? 4. Once again, is it faster to plug in this light blue, or if we plugged into this? Light blue. We could have done each of those by plugging it into the black equation each time instead, and solving for y each time. What's going to happen is you end up repeating the subtraction of 6x and dividing every time. You end up repeating, subtracting, and dividing every time. Whereas here, we did that once, and now we just have to multiply, subtract, multiply, subtract, multiply, subtract. We're done. Does that make sense? Legit, does that make sense?
Yes. Yeah.
Alright, continuing on. I want everyone to stand up. Stand up. Stand up. Stand up. Stand up. Stand up. Okay. Stand up. Stand up. Alright, focus back in. Using formulas. Sometimes solving a formula for a specific variable will help you solve the problem, kind of like we just did. When using formulas, sometimes we want to use this thing called dimensional analysis. You might have heard it called unit analysis. Have anyone heard of this before? Dimensional or unit analysis, maybe in science class?
No.
Wait, is that your D?
Yes. You never wrote formula today? How do you do your lowercase
Your
d?
9 and D's will look like too.
My 9 and my D?
Look at
Yeah.
My D.
I was like,
O-L-I-N-E.
Okay. It's the process of carrying units through multiplication, okay? So converting from maybe millimeters to inches, or millimeters to meters, okay? So we're going to do a couple problems, and they both have an A and a B part here. A car's fuel economy, probably pretty important to know, right? You want to know what kind of economy your fuel your car is getting, because it tells you how often you need to fill up, that kind of stuff, your driving habits. Okay, the better your fuel economy, the less money you're going to spend on gas, okay? Like for example, my wife and I's got a couple new cars. One of them, the one I'm driving more, It ends up getting 30 miles to the gallon. That's amazing, okay? I don't have to fill up except for like every 2 weeks. Before, when I was driving a Jeep, okay, I got like 19 miles to the gallon. I would have to fill up just about every single week, okay? And so I save a lot of money right now because I'm driving a car with better mileage, okay? So car's fuel economy, we'll call it capital E, in miles per gallon, okay? Number of miles driven per gallon of gas. Is given by the formula, capital E is equal to M over G. Efficiency is equal to miles over gallons, where M is the number of miles and driven, and G is the number of gallons of fuel used. So first thing, we want to solve this formula for M. So we have this formula, capital E equals M over G. Let's solve this formula for M. Let's solve for miles. So how would we solve this formula for M? I want you guys to try it. Solving this equation, E equals M over G for M. I want you guys to try to solve it.
Oh, fire. Oh.
Yes.
Love the letters.
What?
Okay. How would you solve it if it was 5 equals M over 4?
No, I
Okay. If
M
you're
over-
having trouble solving this one for M,
Oh, M over
if you're having trouble solving this one for M, for 10, it's something like this. I just replaced the other two variables we're not using with numbers.
Oh.
Would you know how to solve this?
Yeah.
Do the same idea, but instead of 5, it's G. Instead of 4, it's E. I just picked random numbers.
Oh, okay. So
Okay.
Oh, so 4 equals M.
To solve them the same way you would do this, but with V's instead. So what would we do here for the light blue? Multiply by 5, right? Or 5 over 1. So in the purple, what are we going to multiply by?
G.
G. Or G over 1. Now here, we could do 5 times 4 and get 20, right? Can we do G times E and get anything? No, it's
No.
just G times E, we leave it. Here, these 5 simplify out, don't they? And look with M. Here, do these G's simplify out? Yeah, they will. Yeah, they're both G's. A G divided by G, do 1. Or for them. Did we get M by itself?
Yeah.
Yeah.
You did it for us.
Okay, I know.
Thank you.
Okay. Does that make any more sense though?
Yes, it does.
Okay. And no. Okay? So we follow the same steps we would if there were numbers there. We follow the same steps we would have if there are numbers there, which we've learned, okay?
Okay.
Okay. So, part B. Let's say Claudia, the student named Claudia. Claudia's car has an average fuel consumption of 30 miles to the gallon. It's really good. And she used 9.5 gallons. How far did she drive? How far? What unit is that? Far. We're talking about miles, gallons, or fuel economy?
Miles.
Probably miles. How far? Okay? Now, what are we given? For an average fuel consumption of 30 miles per gallon, is that going to be E or G?
What?
We said how far we're driving, that's going to be M, or miles. For fuel consumption of 30 miles per gallon, is that going to be our E or our G? It's going to be our E, our fuel economy. Our economy, E, is in miles per gallon. Miles per gallon. She used 9.5 gallons. 9.5 gallons would be what letter?
G.
G, that's our G for gallons of fuel. So can we plug this M, this E, and this G into our formula?
Yeah.
Yeah. What are we solving for here? What variable? What are we
And
Do we have an equation that's already solved for M?
Yeah.
So we can plug it in here, and it'd be easier than plugging in here, wouldn't we?
uh-huh.
So let's plug it in. So instead of G times E equals M, we'd have what times what?
9.5
Times
30.
30. And that would equal whatever our M is. I'll write that down if you haven't. And it might be a good idea to put the underline E, underline G, underline M, just because that's what we did in class here. So I'll be see it, okay? Boys, you want to put your heads down, please? Boys in the hood. Okay, so now we're actually going to multiply this. 9.5 times 30. What's 0 times 5 and 0 times 9? Just 0, right? We can just kind of drop a 0. What's 3 times 5? 15. Put the 5 down, carry the 1. What's 3 times 9? 27 plus 1? 28. How many numbers started behind the decimal? 1. How many numbers end behind the decimal? 1. So how far did Claudia drive? 285 miles. So on 9.5 gallons of gas, she was able to go 285 miles.
Wait, do you live in Platinum or?
I actually live in Bellevue.
Ew, you have to drive 15 minutes to work.
Oh,
That's
yeah.
not that.
15 minutes isn't bad at all. I'll take it.
Does it take you 15
I mean,
minutes?
he doesn't have to drive for
It's
the whole
15 to 20. Depending on the day, depending on traffic. But, so this is handier that we already solved for M, because it made it easier to plug it in. Otherwise, we would have had this original equation, and we would have plugged it in there, and we would have had 30 equals M divided by 9.5. Is that a little bit more work than this? Or maybe is it a little more complicated? Okay, either way we multiply by 9.5, we get the same answer. But this one's a little more complicated. So we already solved for M, and we just plugged it in. Okay, we plugged the formula in. We plugged in what we knew and solved for what we didn't. Questions on that? Okay, continuing on. What? Oh. You guys have the other example?
Yeah.
Weird.
Do we
Oh,
need
we
it?
should have said no.
No.
We
No,
don't have
we
it.
definitely don't have it.
No.
No,
It's just
we don't.
What is this?
I don't have it.
We'll talk about it briefly. We'll just do part A briefly, okay?
I'd rather do that than do it.
That's fair.
Sure.
The formula for the volume of the cylinder is V equals pi r squared times h, where r is the radius. So r is the radius. H is the height. And we're asked to solve for h. We're asked to solve for h. Okay, what's happening with h right now? Multiplying with what? Pi and r squared. How do we undo multiplication? Division. So what are we going to divide by? We want h.
No,
R squared and what else? Pi. Is that going to reduce those? That's good. That's what we want. So I have to reduce the other side by pi r squared as well. Now, do we know volume V divided by pi r squared? No, but we can write it. And that equals what? H. We solve for height.
Oh, that's easier than I thought it was.
Thank you.
Yeah, that looks really confusing at first.
I did think it.
Oh.
I appreciate it, honestly.
What'd she say?
They gotta pay attention.
Oh.
We have one more.
No.
No.
Be quiet, Mason.
We're gonna skip that one.
Heck yeah.
Why
You
do
kiss
you
him out.
No. Those, the no packets are for you. The no packets are for you. They're yours. I want them to help you.
I'm saving your history for tape.
Perfect. All right. So.
Max. No. There you go.
So before we were in math class,
Yeah.
they kind of math.
Not all the time.
Are you guys letting it? You letting it pod yet?
Yeah.
All of them?
Yep. All of them. I mean. Okay.
I mean, you can choose
Yeah.
all of them. You just get a bad grade.
That's true. All right. And we're gonna put Snapchat away.
We are?
We are.
I didn't know that.
Oh, you totally did.
I felt like did not.
Oh, okay. All right.
Just.
You can tell Mr. Rubio hi later, okay? So we're going to do this worksheet. There's a front and a back. Okay, there's a front and a back. 8 on the front, 7 on the back, 15 total. Okay, we're going to do all of it. Tells you on each individual problem what to solve for. Okay.
Can I finish this one?
I would work on this one first, so that way it's fresh and you can ask me questions here. Okay.
Yes, sir.
Yes, sir.
My mind just went blank.
Music.
You guys
question mark?
can listen to music,
Okay.
but just don't let it be a distraction to you. Okay.
It won't.
I used that thing over there.
What?
The,
What?
The bathroom?
that thing over there.
Ew.
The R.
Oh, the restroom.
Yeah, I can't say it.
Yeah. Oh, really?
What do you think?
Max.
But I said
What'd you say?
the restroom.
I don't know what.
The restroom.
I mean, you can always say bathroom.